So today there's not any new material that we're covering. It's the same stuff, just more practice, and we're also going to get into some proofs with this stuff as well. So still looking at two parallel lines cut by the transversal, and that's how all of these problems are going to start, with that information given to us. But we can't just assume that. We have to know that. And looking at this picture, without me coloring all over it, what do we notice?
Well, I see two parallel lines cut by a transversal.
Absolutely. So because we know that, we have some special angle pairs.
Perfect.
Now, they're asking us in this one to find the value of x. Ooh, that's kind of nice. Usually they ask for the angle measure. This time we get to stop as soon as we know what x is. Looking at where this x is located in this expression of 4x plus 4, that angle, what do you notice about it?
Well, I notice it is a special angle pair with the other angle that's labeled 92. And because those are parallel lines cut by a transversal, those two angles are congruent.
Good. And why do we know that? What kind of angles are they?
Those are alternate interior angles.
So we know, because of the alternate interior angle theorem, that these two angles are congruent, meaning that their measures are
Equal.
4x plus 4 is equal to 92. And then from there we can go ahead and solve, and we'd end up with 4x is
Equal to 88.
And when we divide both sides by 4,
X is 22.
X is 22. All they asked for was the value of x, so we already have our value of x.
Okay. Now, and one thing she did, Miss Hograby kind of did in her picture, because part of it is also explaining your reasoning.
Yes.
And she just got excited that she got the value of x.
We were there.
So going back real quick, she mentioned this over here. So you don't have to put it in the picture, because sometimes the picture, is on a worksheet, and we want you to keep your worksheets, class set. We want to keep it. So kind of putting it right here would be perfectly fine as well, because that gives you support. Why do I know this? You don't need to give me, okay, I
used SPO and then DPO.
No.
Yeah.
This is the big one. This is really, how did I get this equation? And then go ahead and answer it. And again, you could check your work, put it back in to see if it actually gets you 92.
And the theorems are perfectly great reasons. That's what we're looking for.
Theorems, definitions, postulates, all of those things are going to be reasons when we get to our proofs as well. So again, same directions, find the value of x, and then explain your reasoning. So I look at that picture. Hopefully you're doing the same thing. And what do you notice that's kind of important about the picture that we have to know in order to really do anything?
We have two parallel lines that are cut by a transversal.
So parallel lines cut by a transversal. And when you look at the values that are labeled in that picture, the angles I should say, and more specifically where x is, notice in this expression and then this angle, a lot of times what I ask myself is, are they a special angle pair?
Yeah, and looking at these, they're not.
Okay.
Because one's in the interior, one's in the exterior, and they're not corresponding angles, so that's not going to work.
But is there, based on the fact that these are parallel, right, is there a special angle pair that we could find to make that, where we could find that value of x?
Sure. In fact, I'm looking at the angle that's marked with the 25 degrees.
Okay.
And I know that right kind of almost above it,
So right here.
that would be a corresponding angle to the one that we're given. And I know that those two are a linear pair.
Okay, so the angle she's talking about, I'm just gonna label this angle 1. And she's basically saying that the angle right above the angle 25 is a linear pair to that angle that's 25. So
Right.
if these are a linear pair, what does that mean about those angles?
That means that they are supplementary.
Okay, so I know if the supplementary means they add up to 180. So I'm just going to call that angle 1 and say that plus 25 is equal to 180.
Okay.
And that's because of, what would be a good reason for that?
That would be because of the linear pair postulate.
So we do have to explain kind of how we're getting that other angle, so that way we can use that to find angle x.
Right.
Or the value of angle, for a value of x. So angle 1 ends up being
155.
All right, so I'm going to go back to the picture, and I'm going to put that, this is 155 degrees. All right, now going with what you were saying, Mrs. Hograby, you were saying this 155 And the 4x minus 3x are what kind of special angle pair?
Those are corresponding angles.
And if those are parallel lines and those are corresponding, what's true about those corresponding angles?
That they are congruent as long as we've got the parallels.
So this angle is congruent to that angle. So I could say, basically, if they're congruent, that means their measures are equal. So I could say 155 is equal to 44 minus 3x, right?
Perfect.
And that's because of
the corresponding angles postulate.
Now, going back here, you could actually, I'm thinking you could use corresponding angles postulate and find this one and say that's 25. Then you could use linear pair. So there's a variety of ways you could use vertical angles because you have so many special angle pairs in this picture.
Right.
All right, so we're going to go and do a little solving here. So this is
111.
11 equals a negative
3x.
3x.
And then when we divide by our negative 3, we're left with 37. Negative 37.
Yeah. Now, it said find the value of x. We did it. Now, we get a value of x that's negative. Does that mean it's wrong? Because a lot of times when we're finding this, we're like, well, negative value, this is dealing with angles. Is that an actual angle?
That's not the actual angle. In fact, I'm looking up at the angle where x is, and I noticed that that negative 3 is being taken times that negative 37.
So if I was checking this, I could do 44
positive.
Minus 3 times a negative 37.
Right.
So this would be 44, basically, plus whatever that is.
111.
And then this ends up being 100 or 111, and then you add that, you get
your 155,
which is what you need it to be.
Exactly.
All right, so don't just, immediately think, oh, I did something wrong. It worked out.
Exactly. Perfect.
All right, now let's try some proofs because we did some of this little algebra stuff yesterday. Let's see if we can apply these special angle pairs with parallel involving some proofs.
All right. And we know we've got some given information. We know that our first step is that line N is parallel to line P. Sometimes it'll be marked in the picture, but typically in a proof, you're going to see it just as your given information, and we'll be marking that in our picture. Now notice that's the only thing that we're given, is that N is parallel to P.
So not a lot.
Not a lot. We're trying to prove that angle 1 and angle 2 are supplementary. Now, I'm just going to stop and think for a second. Are 1 and angle 2, are those two angles a special angle pair?
No, they're not.
They're not. Again, one's interior, one's exterior, and they're not corresponding.
Okay.
So looking at those, I can't just immediately assume that I know any of that information.
Okay.
Based off of the parallel lines that we know. But do we have some special angle pairs that we do know?
Yeah, and so all we know, like you were saying, we have parallel lines. And when you see parallel lines, you should immediately, like Mrs. O'Gravy, that's your name, you know parallel, which automatically means you have some special angle pairs. Now, I'm thinking, based on the parallel, that I see angle 1 and angle 3. Those two angles are corresponding angles, and since those are parallel, they're going to be congruent. So angle 1 is congruent to angle 3, and I love how Mrs. O'Gravy's labeling that in the picture. Okay, label. It's going to help you kind of get a visual.
Yes.
So corresponding angles postulate.
Wonderful. Notice that, again, we've listed these reasons before. This is not anything different. It's just now we've got our two columns to be able to separate it. So we know that these two angles are congruent, angle 1 and angle 3, because of the corresponding angles postulate. Okay. Do you see another set of angles? Because angle 1 and angle 3 being congruent is not what I'm trying to prove.
Okay, so I'm gonna kind of backtrack for a second. If I'm trying to prove angle 1 and 2 are supplementary, the only way, and this is going back to like chapter 2, the only way to prove supplementary angles is to show they add up to 180.
Yes.
So I'm looking at that picture. I've already used the fact I don't see any other like special angle pairs in relationship to the parallel, but I do see some special angle pairs like angle 2 and angle 3, right? Aren't those a special angle pair?
Angle 2 and angle 3 are. What do we know about them?
Those are going to be supplementary because they're a linear pair. So definition of linear pair?
That is the definition of linear pair is when I've got two, that's just describing them. That's saying that I've got two adjacent angles whose non-common sides are opposite rays with a straight line. So I don't want to say definition.
The linear pair postulate.
Linear
so
pair
LPP,
postulate. Perfect.
And which we use a lot in chapter 2.
A lot.
Okay.
All right, now notice what I'm trying to prove. I'm trying to prove that 1 and 2 are supplementary. I know that 2 and 3 are supplementary, but I can't go straight to saying that 1 and 2 are supplementary.
I can't just substitute angle 1 into angle 3 and say angle 2 and angle 1 are supplementary?
Right, we can't substitute into a statement.
Okay.
But I think you're getting the idea that we probably will need to be doing something with an equation to be able to do some substitution.
And like you were saying, the only way that we can substitute, because we got to have that equation. So I don't have an equation from that. So I'm just going to feed off what we just said. So I know if angles are supplementary, then they add up to 180. So angle 2 and angle 3, those measures are equal to 180. And that's because of the definition of supplementary.
Okay.
Now,
I still
again, I only have one equation, and if I want to use my second piece,
I've really already talked about the parallel,
and I've used step 3, right?
Mm-hmm.
So if only way I can use angle 1 is congruent to angle 3 with statement 4 is I got to change it over to equality. So angle 1 is equal to angle 3. As those measures, that reason would be definition of congruence, which we use that.
Use that a lot
in chapter 2.
Absolutely.
All right, now that I can do that, can I substitute now? I'm so great.
Now we can substitute.
All right, let's put angle 1 in for angle 3 above. And so we can say angle 2, measure angle 2.
Just to be aware that why we're doing that again, notice we're trying to prove that angle 1 and angle 2 are supplementary. So I want to make this, instead of a 2 and a 3, I want to make it a 1 and a 2.
So
perfect.
Measure of angle 2 plus the measure of angle 1 is equal to 180, and that's because of substitution. And I'm only substituting. So that's right. No transitive. And then I can go ahead and say, okay, if they add up to 180, then they're supplementary. So angle 1 and angle 2 are supplementary.
Love it.
And that's because of the definition of supplementary. Now, I will tell you, this is one of the proofs that can be kind of tricky because of the fact that it's it's obvious that that's going to be the case and you just want to go straight there. But remember, in proofs, we don't want to have any gaps. We don't want to do something like substitute when you can't actually substitute because you got to have an equality. All right, so this is definitely one you want to make sure you're good with. Let's try another proof. Now, right away, tell me what you're noticing that's a little different than this from the last one.
Well, now we have 4 lines as opposed to just 3. And in my given, I'm noticing that we've got 2 sets of parallel lines. Oh, this kind of reminds me of the one that we did yesterday in class, or yesterday in notes, that had, the 2 sets of parallels we really have to look at.
So let me label that right away. We always want to label if there's something in the given that we can label. And because there's 2 sets of parallel lines, notice I label them differently because they're not all parallel each other. So when you're doing this, kind of like what we were doing yesterday, is kind of focus on one set at a time.
Okay.
So I like to just kind of start with the first one.
Sounds good. So looking at line N and line P being parallel, I noticed that along those, the top transversal, using Q as my transversal, I see 1 and 3, and those are corresponding angles. So because the lines are parallel, I know that angle 1 is congruent to angle 3.
Okay, I'm going to take this away real quick. So angle 1 is congruent to angle 3. And, froze on me. Angle 1 is congruent to angle 3. Man, it's just
it's really freezing.
It's not I swear I know how to write with this thing. Angle 1 is...
we're going to know that's congruent.
Congruent, there we go, to angle 3.
And that's the corresponding angles postulate, because those 2 angles are corresponding.
And now let me go ahead and label it, as long as I don't have issues with the pen. All right, so, and again, that came off of the first part of the given, so we've already used that.
Okay, so now we want to look at Q and R being parallel. And I like how you highlighted your lines. I think that is helpful sometimes to get that visual. And keep in mind, guys, you can draw your own new picture with just that.
Yeah, so let's just look at, and what I mean by that, let me just talk about what I mean by that. So I'm going to draw line Q and line R, and we know those are parallel. Now here's the deal, there's 2 transversals.
Yeah, and it looks like I only see 1 angle at each at each intersection of that transversal along line P.
Okay,
so I really don't need to draw line N with this set because N has an angle that's not a part of this
So like for what she's saying, like if I cover this one up, let me just show you. If I cover up line P, notice line N only has one angle on that transversal. So is that really going to help us?
No.
With those sets. So she's focusing on, if you just draw this transversal.
Skipping again.
Oh, Lord.
It's making you look silly, Mrs.
I
Fuera.
know. You guys, I know, are laughing at me right now, but that's okay. I'm laughing at myself. So this is line or angle 3 and angle 2. So you're looking at those angles. And notice, because those are parallel, all right, to each other, what can we say about those angles?
That they are corresponding angles, and because the lines are parallel, we can say that they're congruent.
So then angle 3 is congruent to angle 2.
And that reason is, again, corresponding angles postulate. Oh, could I have put those in the same step?
Good question. We talked about this in chapter 2, and here's the deal. The question is, do they have the same reason?
Yes.
And do they depend on each other? In other words,
do I have to have one
statement? Can I put angle 3 is congruent to angle 2 before angle 1 is congruent to angle 3?
Sure, I could, because it's just a matter of which order I did the two given information.
So we could have combined them. Now, I've gotten this question in chapter 2 is, people are noticing that they could have combined them. But if you didn't notice it right away, is there any reason to erase and rewrite and do that? No, just leave it. There's nothing wrong with it. So I'm going to go back to this original picture. I already have one tick mark for angle 1 or angle 3. We know that's going to be also one tick mark.
Yeah.
So I've used the given, and I got these statements. So
and actually, before we do, I really want to emphasize something that you did. That you covered up one of those lines. Guys, keep in mind you can use your hands or your fingers to cover pieces up too.
Yeah.
I mean, you don't have to scribble through it necessarily so that you can see it, but you can use your fingers to cover up those lines that you don't want to look at to help you really look for those special angle
So like when I scribbled this one out to kind of see, is that one going to be the transversal? Instead of scribbling, you could use your hand. You could use even a pencil or something just to make it, just so it's easier to visualize it.
It's a great strategy when we've got two sets of parallels.
Yeah, and this is going to help tremendously even in the next section.
Yeah.
All right, so we got the given taken care of.
Okay.
Statement steps 2 and 3.
Oh, steps 2 and 3 both have angle 3 in them, and I want to put angle 1 with angle 2, so I can do that now using the transitive property.
So angle 1 is going to be
congruent to angle 2. Because they're both congruent to the exact same thing, they're congruent to each other. That's the transitive property.
Now what about substitution?
It's congruence, though, and that substitution is only a property of equality.
So if you wanted to use substitution, you could change it all to equality and then substitute and then change it back. But what's the point?
Yeah.
That's why we have this property as well for congruence.